every image of the universe you have ever seen is incomplete. Not inaccurate, exactly. The stars are real. The galaxies are real. The glowing filaments stretching across billions of light years are real. But every diagram, every simulation, every carefully rendered map quietly removes the most important fact about the cosmos, that beyond a certain distance the universe disappears, not because there is nothing there, but because reality itself no longer allows you to see farther. Tonight, above the Earth, the sky appears calm. A thin atmosphere scatters the light of nearby stars. Cities pulse softly against continents. Satellites drift in silence. The moon reflects sunlight that left the sun just over a second ago. Everything feels immediate, local, contained. Human intuition evolved for distances like these. A horizon, a mountain range, a journey across an ocean. Even the solar system resists comprehension. Neptune is so distant that sunlight arriving there has already spent over 4 hours crossing the cold. If the sun suddenly vanished, the planets would continue orbiting peacefully for minutes or hours before learning that their star was gone. Information itself moves slowly. This is the first crack in the illusion, because the universe you experience is not the universe as it exists now. It is the universe as it once was. Every time you look outward, you're looking backward through time. Moonlight is old. Sunlight is older. The nearest star appears as it existed more than 4 years ago. And beyond that, the scales begin to separate from human thought entirely. The Andromeda Galaxy hangs above Earth tonight as a dim smear of ancient light. But the photons entering human eyes began travelling toward this planet long before cities existed. Long before recorded history. Long before human civilization built its first walls beside rivers. Andromeda is not being observed in the present tense. Nothing distant ever is. The deeper astronomers look into space. The further they descend into the past. Great observatories do not simply magnify distant objects. They excavate history itself. The James Webb Space Telescope drifts nearly 1 million miles from Earth in permanent darkness. Shielded from sunlight by layers of reflective film thinner than paper, it searches not merely for galaxies, but for the oldest surviving light in existence. Light emitted when the first stars were igniting inside a young universe still emerging from primordial darkness. Some of those photons began their journey before Earth existed, before the sun existed, before there were planets at all. And yet even these instruments eventually encounter a boundary, a horizon, a place where observation stops. Not because telescopes fail, because the structure of reality imposes a limit beyond which no information can ever arrive. This invisible wall is called the observable universe. The phrase sounds deceptively technical, almost harmless, but hidden inside it is one of the most psychologically disturbing discoveries in modern science. The observable universe is not the whole universe. It is only the portion light has had time to reach, a temporary bubble of visibility surrounding humanity. Current estimates place its diameter at roughly 93 billion light-years. Already the number begins to malfunction inside the human mind. Language was never designed for scales like this. 1 billion seconds is over 30 years. 1 billion miles does not even leave the solar system. Yet here the distances are measured in billions of light years. Not miles, not kilometers. Years converted into distance because ordinary units become meaningless. And even this enormous sphere may be microscopic compared to what actually exists, because the universe has been expanding since the beginning of time. While light travelled toward us, space itself stretched. Galaxies moved farther apart. Ancient photons crossed an expanding ocean, whose size increased continuously beneath them. The observable universe is therefore not a fixed location, but a moving frontier, slowly revealing older layers of cosmic history while permanently concealing everything beyond its reach. There are galaxies whose light will never arrive here. Not eventually, never. No future civilization will see them. No telescope will image them. No message travelling at light speed could ever bridge the distance separating those regions from our own. They already lie beyond contact, beyond causality itself, and what exists there remains unknown. This is where the emotional structure of the universe begins to change. Most people imagine space as empty but understandable, a giant landscape extending outward forever, waiting patiently to be explored. But the real cosmos behaves less like an open territory and more like an island of temporary illumination surrounded by permanent darkness. The observable universe is not simply large, it is isolated. Human civilization exists inside a sphere of ancient light suspended within something potentially far larger than observation can access. Beyond that sphere may be endless galaxies, endless stars, endless structures larger than anything humans will ever detect, or something stranger. Different laws, different physics, different beginnings. Scientists do not know. What unsettles cosmologists is not merely the scale of the unknown, it is the realization that some unknowns may be fundamentally unreachable. For centuries, human progress carried an implicit assumption that ignorance was temporary. There were mysteries, certainly, but eventually, with better instruments, deeper mathematics, or longer exploration, reality would surrender its answers. The observable universe quietly destroys that assumption, because there may be regions of existence forever sealed beyond the horizon of knowledge itself, not hidden temporarily, hidden by the architecture of space-time. Even now, as you sit beneath the night sky, reality extends outward into distances so enormous that the light from those regions has not had enough time to arrive since the birth of the cosmos 13.8 billion years ago, and perhaps never will, which means the visible universe, all galaxies, all stars, all recorded history, every human memory, every war, every religion, every ocean, every extinct species, every sleeping city under tonight's sky may occupy only a tiny bright fragment inside something vastly larger and permanently unseen, a small clearing in an infinite dark, and the deeper science investigates this darkness, the less comforting the picture becomes. For most of human history, the universe appeared small enough to belong to us. The sky arched overhead like a ceiling. The stars rotated with reliable precision. The sun rose and disappeared. Seasons returned. Constellations repeated themselves across generations so consistently that entire civilizations attached stories to them. Hunters navigated by them. Sailors trusted them. Priests built cosmologies around them. Reality seemed structured around human experience. Even after the scientific revolution displaced Earth from the center of creation, the emotional model remained strangely intact. The solar system became larger. Then the Milky Way expanded outward into incomprehensible size. Later, astronomers discovered that the faint spiral smudges in telescopes were not clouds inside our galaxy, but entirely separate galaxies themselves. The scale changed, but the underlying assumption survived, that the universe was ultimately visible, ultimately understandable, ultimately reachable. Humanity continued imagining reality as something that could, in principle, be mapped. A frontier. This assumption hides inside nearly every artistic rendering of the cosmos. Galaxies drift elegantly across black space. Nebulae bloom with colour. Stars appear scattered across a manageable darkness. Even the phrase outer space carries psychological comfort. It suggests a place one could travel through, a distant ocean waiting to be crossed. But the real universe is not organised around human intuition. It only appears that way from inside an extremely limited perspective. The Earth itself contributes to this illusion. Human beings evolved on the surface of a warm planet wrapped in atmosphere and light. Every survival instinct developed inside environments where distance remained physically meaningful. A mountain could be crossed, a forest explored, a coastline eventually reached. The human brain is therefore built for finite spaces. This becomes obvious the moment astronomy introduces genuine cosmic scale. If Earth were reduced to the size of a grain of sand, the Sun would still sit several meters away. Neptune would orbit nearly a kilometer distant, and the nearest star beyond the solar system would remain thousands of kilometers farther still. Not the nearest galaxy, the nearest star. Even this comparison fails emotionally because the mind keeps shrinking the distances back into familiar proportion. Imagination compresses reality automatically. Otherwise, the scales become psychologically unusable. Astronomers themselves struggle against this cognitive limitation. Numbers alone do not solve the problem. A light year sounds abstract until it is translated properly. Light travels at nearly 300,000 kilometers every second, fast enough to circle Earth more than 7 times in a single heartbeat. At that speed, sunlight reaches Earth in just over 8 minutes. And yet after leaving the solar system, light requires more than 4 years to reach the nearest star. 4 continuous years moving at the fastest speed physically possible. Human civilization crossed oceans with wooden ships before the nearest stars became remotely accessible even in theory. The Milky Way then expands the scale further into something almost biologically incompatible with comprehension. Our galaxy contains hundreds of billions of stars. Its diameter stretches roughly 100,000 light-years from edge to edge. If a beam of light began crossing the Milky Way when early humans first painted caves, it would not yet have travelled even 1% of the distance. Recorded history occupies almost no measurable portion of galactic time. Entire empires rise and vanish faster than stars complete small movements around the galaxy's centre. But even the Milky Way is not unusual. It is one galaxy among perhaps 2 trillion inside the observable universe. This is where the comfortable human picture begins quietly collapsing, because most people imagine galaxies distributed through space somewhat evenly, like islands across an ocean. But the universe is far stranger. Galaxies gather into clusters. Clusters gather into superclusters. Superclusters stretch into colossal filaments spanning hundreds of millions of light-years. Between them lie voids so enormous that entire galaxies may drift for unimaginable durations without encountering another major structure. The cosmos resembles less a starfield and more a web, a gigantic skeletal architecture suspended in darkness, and humanity exists somewhere inside one tiny strand. The observable universe itself contains enough stars that every grain of sand on Earth could represent entire galaxies, each filled with billions of suns. Around many of those suns orbit planets. Around some of those planets, chemistry may have awakened into biology somewhere. Perhaps civilizations emerged beneath alien skies and began asking the same questions humans ask now. But distance transforms possibility into silence. Even radio signals weaken into background noise across interstellar space. The earliest television broadcasts from Earth have travelled outward for less than a century, not even enough time to reach most nearby stars. Human civilization has announced its existence to only a microscopic fraction of the galaxy. The universe remains almost entirely unaware that humanity exists, and humanity remains almost entirely unaware of the universe. This asymmetry becomes more disturbing the deeper observation advances, because telescopes do not merely reveal more objects, they reveal how much has always been hidden. When the Hubble Space Telescope stared into a seemingly empty region of darkness for several uninterrupted days in 1995, scientists expected perhaps a few distant galaxies. Instead, the image revealed thousands. An apparently blank patch of sky turned out to contain entire galactic populations extending across cosmic history. Every dark region concealed more structure, more depth, more unreachable distance. The lesson was unsettling. Human beings had mistaken observational limitation for emptiness. The darkness between visible objects was not empty space waiting to be explored. It was reality extending beyond the sensitivity of human instruments, and each improvement in those instruments only enlarged the unknown further. The James Webb Space Telescope deepened this crisis dramatically. Its infrared vision began detecting mature galaxies existing far earlier in cosmic history, than many models predicted possible. Structures appeared where the young universe should still have been chaotic and primitive. Again, the universe refused to behave according to comfortable expectation. Again, reality proved older, larger, and more structurally complex than anticipated. This pattern repeats continuously throughout astronomy. Every expansion of knowledge expands ignorance faster. Every solved mystery exposes larger unknowns surrounding it. Humanity once feared that science would eventually make the universe feel mechanical and emotionally empty, but the opposite occurred. The deeper science investigates reality, the stranger and less emotionally manageable the cosmos becomes. Because the observable universe is not simply difficult to imagine. It may represent only the smallest accessible fraction of existence itself. And this changes the emotional meaning of the night sky completely. When ancient civilizations looked upward, they saw a ceiling decorated with stars. Modern civilization sees something far more unsettling. A thin sphere of detectable light surrounding an isolated species on a temporary planet, orbiting one ordinary star inside one ordinary galaxy among trillions. Beyond that sphere lies darkness, not because the universe ends there, but because human observation does. And somewhere beyond that invisible boundary, reality continues without us. The observable universe is often described as a sphere surrounding Earth. This creates a dangerous misunderstanding immediately. It suggests humanity occupies the center, but every observer, anywhere in the cosmos, would see the same thing: a surrounding horizon beyond which light has not yet had time to arrive. The observable universe is not a privileged location. It is a consequence of time itself, a prison built from the finite speed of light. This is the point where ordinary intuition finally begins to fail completely. Human beings experience reality as simultaneous. Somewhere tonight, rain falls over oceans, somewhere else. Cities remain awake beneath artificial light. Somewhere a child looks upward at the moon while another person closes their eyes for the last time. The brain assumes these events coexist in one shared present. Cosmology quietly destroys this certainty, because there is no universal present stretching across the universe, only isolated local moments separated by immense distances and delayed information. Even the sun you see is already 8 minutes old. If the sun vanished right now, Earth would continue receiving its light peacefully, while catastrophe had technically already occurred. Cause and awareness are separated. The deeper one looks into space, the more severe this separation becomes. When astronomers observe a galaxy 1 billion light-years away, they are not seeing distance alone. They are seeing 1 billion years into the past. The galaxy may already have transformed completely. Stars visible in telescopes may have died before multicellular life emerged on Earth. Some galaxies observed today no longer exist in the form we see them. The night sky is partially composed of ghosts. This realization altered astronomy profoundly during the 20th century. Telescopes stopped functioning merely as instruments of observation and became machines for viewing time itself. Looking outward meant descending backward through cosmic history layer by layer. Nearby stars revealed recent history. Distant galaxies revealed ancient history. At sufficient distance, the universe becomes so young that entire structures vanish. Galaxies grow smaller, more chaotic, more primitive. Heavy elements become rare. The first generations of stars ignite inside darkness untouched by planets, biology, or memory. The universe itself begins emerging from infancy, and eventually astronomers encounter a wall. Not a physical wall, a thermal one, a horizon of ancient radiation surrounding the observable universe in every direction. The cosmic microwave background. At first glance, it appears almost disappointingly simple. A faint bath of microwave energy distributed across the sky. Static, noise, a weak glow only a few degrees above absolute zero. But this radiation is among the most important discoveries in human history, because it is the oldest light humanity can observe. Before its discovery in 1965, cosmologists debated whether the universe had always existed in roughly its current form, or whether it had originated from an earlier dense state. The microwave background resolved the argument with terrifying clarity. The universe had a beginning, not necessarily the ultimate beginning of existence itself, but a beginning to observable cosmic history. Roughly 380,000 years after the Big Bang, the expanding universe cooled enough for atoms to form. Before this moment, space was so hot and dense that light could not travel freely. Photons scattered constantly through a plasma resembling the interior of a star. The cosmos was opaque. Then suddenly transparency emerged. Light decoupled from matter and began moving freely through space. Some of that ancient light still travels across the universe today, and eventually, after nearly 14 billion years of uninterrupted motion, tiny fragments of it entered human instruments. Civilization discovered the afterglow of creation itself. But the deeper implication is far stranger. The cosmic microwave background is not merely old light, it is a visibility limit, a boundary beyond which human observation cannot directly pass. Before that era, the universe becomes hidden behind opacity. Earlier events may still leave indirect fingerprints through gravitational waves or subtle quantum effects, but ordinary light cannot reveal them. The universe before transparency remains physically obscured. There are moments in cosmic history that humanity may never witness directly. Already the structure of reality is becoming psychologically uncomfortable, not only because the universe is large, but because knowledge itself appears fragmented and incomplete at fundamental levels. Human beings instinctively assume that enough technological progress can overcome any barrier. Yet modern cosmology repeatedly encounters limits that are not technological but physical. Certain information may simply never reach us, and this problem worsens dramatically because the universe is expanding, not expanding into surrounding emptiness. As human language naturally imagines, space itself expands internally. Distances between galaxies increase because the fabric of space-time stretches continuously everywhere at once. This expansion produces one of the most counterintuitive realities in science. Very distant galaxies are receding from us faster than light, not because they violate relativity. Locally, nothing outruns light through space. Instead, space itself expands between distant regions, carrying galaxies apart faster than light can bridge the increasing separation. The implications become severe. Imagine standing on a shoreline while the ocean itself expands faster than a swimmer can move. No matter how long they travel, the distance continues increasing beyond recovery. This is already happening across enormous regions of the cosmos. Some galaxies visible today emitted their light when they were much closer to us billions of years ago. But during the journey of that light, cosmic expansions stretch space so dramatically that those galaxies now lie vastly farther away than the photon's original travel distance suggests, and many have crossed a deeper threshold, a cosmic event horizon. Beyond this boundary, expansion outpaces the future ability of light to ever reach Earth again. Photons emitted now from those galaxies will never arrive here, no matter how long civilization survives. The observable universe therefore contains objects that are already permanently disappearing, not visually vanishing all at once, but slowly fading beyond causal contact with humanity forever. Future astronomers living trillions of years from now may see a radically emptier cosmos. Nearby galaxies within our local gravitational group will remain visible, but most distant galaxies will have redshifted into invisibility as expansion carries them beyond observational reach. Civilization currently exists during a surprisingly fortunate period of cosmic history, early enough to still observe evidence of the larger universe. Eventually, much of that evidence will vanish. Future intelligent species may conclude they inhabit a lonely static galaxy surrounded by eternal darkness, because the expanding universe will conceal its own past from them. The cosmos erases itself gradually. Even now, the observable universe is not a complete portrait of existence. It is a temporary snapshot assembled from ancient light arriving during one brief interval of cosmic time. Humanity mistakes this snapshot for reality because it is all we can access. But beyond the horizon, beyond the oldest visible radiation, beyond the distance where space-time expansion permanently severs contact, the universe continues outward into regions that may remain forever inaccessible. And this is where astronomy begins transforming into something more unsettling than science alone. Because once observation reaches its limit, imagination becomes unavoidable. For centuries, ignorance carried a certain comfort. What humanity did not understand could eventually be discovered. Unknown coastlines could be mapped, hidden continents could be crossed, diseases could be studied, planets could be reached. The assumption beneath science was always that reality remained fundamentally accessible, that the universe, however complicated, was still available to observation. But modern cosmology has introduced a far more unsettling possibility, that some parts of existence may be permanently beyond explanation, not because humans are primitive, but because reality itself prevents access. This is where the picture begins to break down. Because the observable universe is not simply incomplete, it may be catastrophically incomplete. To understand why, it helps to imagine standing alone in the middle of a vast ocean at night. Your vision extends only as far as the weak circle illuminated around you. Beyond that light, the ocean continues invisibly in every direction. You naturally assume the darkness hides more water similar to what you already know. But this assumption rests entirely on faith. You cannot actually see beyond the boundary. The observable universe creates the same psychological trap. Human beings quietly assume the unseen cosmos resembles the visible cosmos, simply because no alternative can yet be proven. Galaxies beyond the horizon are expected to obey the same physics. Space beyond observation is assumed to continue smoothly, and perhaps it does, but cosmology can no longer guarantee this. Because the observable universe may represent only one local region inside something much larger and structurally stranger. The first signs of this emerge from a problem that initially seemed almost absurdly technical. The universe appears too smooth. When astronomers measure the cosmic microwave background, the oldest visible radiation in existence, they find nearly identical temperatures across regions of space, separated by enormous distances. Areas billions of light-years apart contain astonishingly similar energy distributions. This should not happen. Those regions are so widely separated that, according to ordinary expansion models, they could never have exchanged information or energy. There has not been enough time since the Big Bang for light or any causal influence to travel between them. The young universe somehow coordinated itself across impossible distances. This became known as the horizon problem, and its implications were deeply uncomfortable, because either the universe began in an almost impossibly fine-tuned state, or something enormous happened very early in cosmic history that radically altered space-time itself. Most cosmologists now favour the second explanation, cosmic inflation. The idea sounds deceptively simple at first. In the earliest fraction of a second after the Big Bang, the universe may have undergone a period of expansion so violently extreme that space-time itself doubled in size again and again at unimaginable speed. Not over millions of years, not over seconds, but during intervals so short that human language struggles to describe them meaningfully, in less than a trillionth of a trillionth of a trillionth of a second. Reality may have expanded from subatomic scale to astronomical size, and the consequences of this possibility are difficult to emotionally survive once fully understood, because inflation changes the emotional meaning of the observable universe completely. Without inflation, the observable universe feels enormous but singular, the totality of everything humans can ever hope to explore. With inflation, the observable universe becomes something smaller, potentially much smaller, a tiny surviving patch inside a vastly larger cosmic structure expanding far beyond human visibility. This is where scale becomes psychologically dangerous. The observable universe already contains trillions of galaxies and distances so large that human civilization disappears mathematically inside them. But inflation implies that even this gigantic region may be microscopic relative to the whole. like a single air bubble trapped inside a planetary ocean. And there may be countless other bubbles. The mathematics of inflation produce an unsettling side effect. In many models, inflation never fully stops. Certain regions of space-time cease inflating and form local universes like our own, while surrounding regions continue expanding exponentially forever. This creates what physicists call eternal inflation, a cosmos generating disconnected universes endlessly. Not science fiction universes with magical laws and fantasy worlds. The scientific models are colder than that, more indifferent. Each region may contain different physical conditions, different constants, different arrangements of matter and energy. Some may collapse instantly, some may remain empty forever, some may never form stars. A few might resemble ours closely enough for galaxies and observers to emerge. The observable universe would then represent not the universe, but one habitable pocket among incomprehensible numbers of inaccessible regions. Humanity would occupy a local accident, and no signal could ever cross between these cosmic domains, because inflation expands the intervening space faster than information can travel. The separation is absolute. Entire universes may coexist beyond the observable horizon while remaining permanently unreachable. Even the word distance begins failing here. These regions are not merely far away in the ordinary sense. They may be causally disconnected forever, separated by expanding space-time itself. Reality becomes fragmented. And this introduces a terrifying philosophical reversal. Human civilization has long feared isolation within the universe, the possibility that intelligent life may be rare among the stars. But inflation introduces a deeper isolation. The possibility that our entire observable cosmos is itself isolated from most of existence. A lonely island of detectable order inside a structure too vast for meaningful contact. And the real problem is even stranger, because inflation itself remains partially unproven. The evidence supporting it is powerful but indirect. It elegantly explains several observed features of the universe, including its large-scale smoothness and geometric flatness. Yet scientists still do not know precisely what mechanism caused inflation, what triggered it, or whether it connects to deeper quantum laws not yet understood. Modern cosmology therefore exists in an unstable psychological position. The current models imply that reality extends far beyond observation, but the physics describing that extension remain incomplete. Humanity stands at the edge of a map whose mathematics continue into darkness. And beyond that edge, the implications grow increasingly difficult to contain, because once the observable universe stops being the whole of existence. Another question emerges naturally. If reality extends forever beyond observation, then what determines the laws governing our local region at all? Why do the constants of physics permit stars, chemistry, planets, biology, and consciousness? Why this arrangement? Why these equations? The deeper cosmology advances, the less inevitable human existence appears. Gravity itself could have differed slightly. Atomic structures could have failed to stabilize. Stars might never have ignited. Space may have expanded too rapidly for galaxies to form. The observable universe balances delicately between forces that, altered even modestly, could have rendered reality sterile and dark. And inflation may imply that such sterile regions exist in enormous numbers. Our universe may not be typical, only survivable, which means every human memory, every work of art, every language, every ocean tide, every extinct species, every sleeping city beneath tonight's atmosphere may exist inside a rare temporary pocket where the laws of physics accidentally permit awareness. A brief island where matter learned to look outward and ask questions, surrounded by expanses forever beyond contact, forever beyond sight, and perhaps forever beyond understanding. There is a distance beyond which the human mind stops experiencing scale correctly. Past a certain threshold, the brain no longer distinguishes between millions, billions, or trillions in any emotionally meaningful way. The numbers flatten together into abstraction. Infinity begins leaking into ordinary thought, Astronomy crossed that threshold long ago, but the universe continues expanding outward regardless of whether human cognition can follow it. This is why cosmologists rely increasingly on comparisons that bypass ordinary intuition, not to simplify the universe, but because direct comprehension has become impossible. Imagine shrinking Earth to the size of a grain of dust. On this scale, the Moon would orbit roughly 30 centimeters away. The Sun would become a glowing sphere several meters distant. The outer planets would drift across neighborhoods and cities. Already, the solar system begins feeling sparse, but the nearest star would still lie thousands of kilometers away, and nearly everything between stars would remain empty. Not empty in the poetic sense, physically empty. Interstellar space is so devoid of matter that even the best vacuums created on Earth are crowded by comparison. A cubic centimeter of deep intergalactic space may contain less than a single atom. The universe is not primarily made of stars or planets. It is made of separation. This becomes emotionally unsettling because human beings instinctively imagine the cosmos as full. The night sky appears dense with light. Science fiction fills the gaps with traffic, civilizations, and movement. But the true structure of the universe is dominated overwhelmingly by absence. Darkness between stars, darkness between galaxies, darkness between clusters. And the distances separating these structures are not temporary obstacles awaiting future travel. They are permanent features of reality, even travelling at the speed of light. Crossing the Milky Way requires 100,000 years. Human civilization would need to survive longer than recorded history, merely to traverse its own galaxy once. At the speed of current spacecraft, the timescales become grotesque. Voyager 1, humanity's most distant probe, has travelled for nearly half a century. It moves faster than any object humans have ever intentionally accelerated beyond the solar system. Yet in all that time, it has crossed only a tiny fraction of the distance to the nearest star. The probe drifts now through darkness so vast that radio messages travelling at light speed still require nearly an entire day to move between Earth and the spacecraft, and Voyager remains gravitationally trapped inside the Milky Way. The galaxy itself becomes smaller and stranger when viewed from larger scales. The Milky Way and Andromeda belong to a modest gravitational structure called the local group, a collection of galaxies bound together across millions of light years. This group itself floats near the edge of a much larger arrangement known as the Virgo supercluster. For decades, humanity imagined superclusters as the largest coherent structures in existence. Then astronomers discovered they were merely components inside something even larger. Laniakea, a colossal cosmic structure spanning over 500 million light-years and containing perhaps 100,000 galaxies. The name comes from Hawaiian tradition and translates roughly as immeasurable heaven. Even this description fails emotionally because the scales involved destroy all biological perspective. Light travelling continuously since before the first dinosaurs still would not have crossed Laniakea completely. The Milky Way occupies one tiny gravitational thread inside this enormous structure. Human civilization exists within a microscopic region of one galaxy among hundreds of thousands drifting through a system so large that Earth disappears mathematically inside it. And yet Laniakea itself may not even qualify as exceptional. The observable universe contains enormous filaments stretching across billions of light years. Galaxies gather along these structures like dew forming on invisible threads. Between them lie cosmic voids so vast that, if the Milky Way occupied their centre, ancient humans would have lived and vanished before detecting another major galaxy. Some voids extend hundreds of millions of light years across. Regions where the universe becomes almost horrifyingly empty. Imagine standing on a planet inside such a void. The night sky there would feel profoundly wrong. Nearby galaxies would be rare. Large portions of the cosmos might appear nearly blank. Entire civilizations could emerge without realizing the universe beyond their local region contained vast galactic populations elsewhere. This possibility unsettles cosmologists because it demonstrates how observational perspective distorts perceived reality. Intelligent species can only infer the universe from local conditions. Humanity already suffers from this limitation. Earth formed beside an ordinary star inside an ordinary galaxy during a relatively early period of cosmic history, when distant galaxies remain visible. These circumstances feel natural only because they are familiar, but they may be extraordinarily temporary. The expansion of the universe ensures that cosmic isolation increases over time. Galaxies beyond the local group are gradually disappearing from observational reach. Their light stretches into longer wavelengths as space-time expands. Over unimaginable durations, distant galaxies will fade into microwave frequencies, then radio frequencies, then effective invisibility. Future observers may inherit a silent sky. This process is not speculative, it is already measurable. The observable universe is slowly becoming lonelier, and this loneliness reveals a deeper truth about cosmic scale. Most of reality is inaccessible not because human beings are weak, but because the architecture of space-time itself prevents connection. No engineering breakthrough changes this. No advanced propulsion solves it. The speed of light is not merely a technological challenge, it appears woven directly into causality. Information cannot outrun it locally, and cosmic expansion increasingly separates distant regions faster than light can bridge them. The universe therefore contains places forever beyond interaction. This idea remains psychologically difficult because human history trains civilization to believe horizons eventually disappear. Oceans once seemed impassable. Continents remained hidden. Mountains blocked exploration. Technology repeatedly conquered distance. Cosmology introduces the first horizon humanity may never overcome, a final frontier that does not yield, and the farther astronomers peer outward, the stranger this horizon becomes, because visible matter stars, planets, gas, dust appears to compose only a small fraction of the cosmos. Galaxies rotate too quickly. Clusters behave too violently. Gravitational lensing reveals hidden mass shaping space-time invisibly across enormous scales. Observations repeatedly indicate the presence of something unseen permeating the universe. Dark matter. No telescope has directly observed it. No laboratory has conclusively identified its particles. Yet its gravitational influence appears everywhere. Entire galaxies may exist embedded inside gigantic halos of invisible matter, outweighing their visible stars several times over. Human beings evolved assuming that reality consists primarily of things that can be seen. Modern cosmology suggests otherwise. Most matter in the universe is invisible, and the situation becomes even more disturbing with dark energy. In 1998, astronomers discovered that cosmic expansion is accelerating. The universe is not merely growing larger. The expansion itself grows faster over time. Something permeating space-time appears to oppose gravity on cosmic scales. Something still poorly understood. Dark energy now seems to dominate the energy content of the universe, which means stars, planets, nebulae, galaxies, and every visible structure humans associate with the cosmos compose only a minor fraction of reality. Most of existence is hidden. Invisible matter, invisible energy, invisible regions beyond the observable horizon. Humanity evolved beneath the illusion of familiarity while embedded inside a cosmos largely inaccessible to direct perception. And this realization changes the emotional character of the night sky permanently, because the stars no longer feel like the substance of the universe. Only scattered sparks drifting across the surface of something far deeper and far stranger than human intuition was ever designed to endure. By the early 20th century, physics had begun to acquire an uncomfortable confidence. Newtonian mechanics explained motion with extraordinary precision. Maxwell unified electricity and magnetism into elegant equations. Thermodynamics described energy, heat, and entropy with devastating reliability. Scientists increasingly believed the universe might ultimately be understandable through a complete mathematical framework. Reality appeared orderly, predictable, perhaps even finite in its complexity, Then the universe started resisting observation itself. The first fractures emerged through light, experiments designed to understand radiation, atomic structure, and energy exchange produced results that classical physics could not explain. Tiny particles behaved like waves. Waves behaved like particles. Measurement itself appeared to influence outcomes. Quantum mechanics entered science not as a triumph of intuition, but as an admission that intuition had failed completely, and cosmology inherited this failure. Because the observable universe does not merely contain strange objects, it appears to emerge from strange laws operating beneath ordinary reality. At the deepest levels currently accessible, the universe resembles less a machine and more a field of probabilistic behavior governed by mathematics that remains astonishingly successful yet philosophically unresolved. Particles flicker into and out of existence through quantum fluctuations. Empty space itself seethes with temporary energy. Vacuum is not truly empty. Space-time may possess microscopic structure invisible at larger scales. The deeper science descends, the less solid reality becomes. And this matters profoundly for understanding what may lie beyond the observable universe, because the larger structures in existence may originate from quantum events unimaginably small. During cosmic inflation, microscopic fluctuations inside the infant universe were stretched across astronomical distances as space-time expanded explosively. Tiny variations in density became the seeds from which galaxies later formed. Every galaxy, every star cluster, every planet, all may trace their existence back to minute quantum irregularities amplified across cosmic scale. Human civilization therefore emerged from ancient fluctuations occurring inside a young universe before atoms, stars, or biology existed. Reality developed structure because perfect uniformity failed. And yet even this explanation exposes deeper uncertainty. Scientists can model inflation mathematically with impressive success. They can simulate structure formation. They can compare predictions against the cosmic microwave background with remarkable accuracy. But no complete theory yet unifies quantum mechanics with gravity. This is one of the greatest unsolved problems in physics. General relativity describes gravity and space-time magnificently at large scales. Quantum mechanics describes microscopic behavior with equal brilliance. Yet when combined under extreme conditions inside black holes or near the beginning of the universe, the equations begin contradicting one another. Reality splits into incompatible descriptions. This is not merely a technical inconvenience. It means humanity currently lacks a coherent explanation for what space-time fundamentally is, and the observable universe may depend entirely upon that missing answer, because once cosmology approaches the earliest measurable moments after the Big Bang, ordinary physics starts collapsing under its own incompleteness. Temperatures become extreme beyond imagination. Density rises toward conditions where known laws cease functioning predictably. Time itself may lose conventional meaning. The phrase before the Big Bang therefore becomes dangerously misleading. Human language assumes time always exists as a flowing sequence. But near the beginning of cosmic expansion, space-time may have behaved so differently that ordinary concepts like before and after stop applying cleanly. Some physicists suspect the Big Bang was not truly a beginning, but a transition. Others propose quantum cosmologies where universes emerge spontaneously from deeper physical states. Some models suggest our universe may exist on the surface of higher dimensional structures invisible to human perception. Others imply space-time itself could be emergent rather than fundamental, a large-scale effect arising from more primitive underlying information. The situation becomes philosophically unstable very quickly, because every layer of explanation now reveals deeper uncertainty beneath it. Humanity once imagined science gradually replacing mystery with certainty. Instead, modern cosmology increasingly resembles an expedition discovering that reality contains deeper levels of incompleteness at every scale, and nowhere is this more emotionally disturbing than inside black holes. Black holes represent regions where gravity compresses matter so intensely that space-time curves inward beyond escape. The boundary surrounding them, the event horizon, marks a limit beyond which information cannot return to the outside universe. Again, reality creates horizons. Again, knowledge encounters physical restriction. At the center of black holes, according to current equations, density rises towards singularities where known physics breaks entirely. Space and time cease behaving coherently. The mathematics diverge toward infinities that most physicists interpret as signs of incomplete understanding rather than literal truth. Nature refuses to reveal what lies inside. This matters because the observable universe itself may contain similar conceptual horizons. The Big Bang resembles a cosmological singularity in many models, a boundary where present theories lose explanatory power. Humanity can approach these edges mathematically, but not cross them cleanly, and the deeper implication is difficult to avoid. The universe may not merely be large beyond comprehension, it may be fundamentally resistant to total comprehension. This possibility emerges repeatedly across modern physics. Quantum uncertainty imposes hard limits on simultaneous measurement. Event horizons conceal information permanently. Cosmic expansion isolates regions causally. The observable universe itself blocks direct access to earlier epochs. Reality contains inaccessible domains everywhere scientists look. Even information may not behave as humans naturally expect. In quantum theory, particles separated by enormous distances can remain entangled, their properties linked in ways Einstein famously described as spooky action at a distance. Measurements performed here correlate instantly with outcomes elsewhere, despite no visible signal travelling between them. The universe appears interconnected beneath space-time in ways still not fully understood, and yet paradoxically, cosmic expansion simultaneously isolates large-scale regions forever. At microscopic scales, reality behaves strangely connected. At cosmic scales, it becomes profoundly disconnected. Human intuition survives neither domain comfortably. This is why cosmology increasingly produces emotional unease even among scientists themselves. Not because the equations fail, but because they succeed while implying a universe profoundly unlike the one human beings evolved expecting. The observable universe feels less like a complete world and more like a temporary window into deeper structures partially concealed by physics itself. And the farther observation advances, the more temporary that window appears. The stars overhead seem eternal from human perspective. But stars burn finite fuel. Galaxies evolve. Black holes evaporate over impossible durations through Hawking radiation. Even protons themselves may eventually decay, though this remains unconfirmed experimentally. Nothing visible appears permanently stable. The universe is not static architecture. It is process, transformation, slow dissolution unfolding across timescales so large that human history disappears instantly inside them. And beyond the observable horizon, those processes continue in regions forever inaccessible to Earth. There may be stars whose light will never reach humanity, black holes whose mergers remain eternally undetected, entire galactic civilizations born and extinguished without causal contact ever becoming possible. Reality extends outward into unreachable events occurring permanently beyond observation. The night sky therefore presents a profound illusion. It appears complete because the brain mistakes visibility for totality. But the observable universe is only the thin layer reality, permits humanity to perceive before distance. Expansion, time, and physics itself close the curtain, and beyond that curtain the universe may become stranger still. The most unsettling discoveries in cosmology are rarely the loudest ones. They do not arrive as explosions or dramatic announcements. They emerge quietly from equations, from small discrepancies in observation, from measurements that refuse to fit comfortably inside familiar expectations. And over time, these quiet irregularities begin altering the emotional structure of reality itself. Because the deeper scientists investigate the observable universe, the less human existence appears central, stable, or even particularly noticeable. The change begins slowly. At first, astronomy merely displaced Earth from the center of the solar system. Then the solar system became one small region inside the Milky Way. Later, the Milky Way became one galaxy among trillions. But now cosmology threatens something larger than physical centrality. It threatens cognitive centrality. The possibility that human beings may occupy not merely a small location in reality, but a deeply limited perspective unable to access most of existence at all. This changes what knowledge means. For centuries, ignorance implied unfinished exploration. There were missing answers somewhere beyond current understanding, waiting to be discovered eventually by future generations. But modern cosmology increasingly suggests there may be truths forever sealed behind physical barriers, not hidden by lack of intelligence, hidden by the structure of the cosmos itself. And this creates a deeply uncomfortable implication. Human civilization may never see reality as it truly is, only the portion permitted by our position inside space-time. This realization becomes especially severe when scientists examine how dependent human understanding is upon local conditions. Every observation humans have ever made emerged from one tiny region of one universe during one brief cosmological era. Even the laws of physics may appear universal simply because all measurements occur inside the same observable domain. This assumption is powerful, necessary, but still an assumption. The deeper issue is difficult to emotionally absorb. If regions beyond the observable universe exist permanently outside causal contact, then humanity cannot directly confirm whether those regions obey identical physical laws. Gravity, electromagnetism, particle masses, quantum constants all may remain local properties of our cosmic neighborhood, rather than eternal universal truths. The observable universe may function less like total reality and more like a single environmental condition, like one climate zone inside a larger planet. And if this possibility sounds abstract, its emotional implications are not, because everything humans consider permanent depends upon the stability of physical law. Stars ignite because certain constants possess precise values. Chemistry functions because electrons obey exact quantum relationships. Carbon forms. Water behaves predictably. Biology emerges. Change those constants modestly, and the universe becomes sterile. No galaxies, no long-lived stars, no planets, no observers asking questions beneath dark skies. Modern physics increasingly recognizes how delicately balanced this arrangement appears. The cosmological constant governing expansion sits at an extraordinarily small value compared to what many quantum theories predict. The strong nuclear force, electromagnetic force, and gravity exist in narrow relationships permitting complex matter to survive. Reality appears finely structured for complexity. This creates one of the deepest philosophical tensions in cosmology. Why does the universe permit observers at all? Some scientists reject the question entirely, arguing that no deeper explanation is necessary. Others invoke the anthropic principle observers naturally emerge only in regions where conditions allow observation. In a sufficiently vast cosmos or multiverse, countless sterile universes may exist alongside rare habitable ones. Humanity would inevitably find itself inside one compatible with consciousness, simply because incompatible universes contain nobody capable of noticing them. The logic is mathematically reasonable. Emotionally, it feels colder, because it removes intention from existence entirely. Human civilization becomes not a planned outcome, but a statistical side effect inside a larger indifferent system generating realities continuously. The stars above Earth then cease feeling personal or symbolic. They become environmental conditions. Temporary thermodynamic structures permitting chemistry to briefly awaken into awareness before returning to silence. And the timeline governing that awareness is disturbingly short. The observable universe is approximately 13.8 billion years old. That sounds ancient from a biological perspective, but cosmologically it may represent an early era. Most stars capable of supporting life have not even formed yet. Red dwarf stars, smaller, dimmer, vastly longer lived than the Sun, may continue burning for trillions of years after larger stars vanish. Human civilization arrived astonishingly early. The universe may spend the overwhelming majority of its lifespan empty of humanity entirely. This thought becomes heavier when combined with cosmic expansion. The galaxies currently visible overhead will not remain visible forever. Over immense timescales, accelerating expansion isolates gravitational structures from one another. Distant galaxies fade beyond observational reach until surviving civilizations inherit progressively darker skies. Eventually, only the local group remains visible, then merged remnants of galaxies, then slowly dying stars. Future observers may never know the larger universe existed at all. The evidence available to modern cosmology is temporary. Reality erases its own history. This is where existential discomfort deepens into something quieter and more profound. Because human beings evolved assuming that truth accumulates over time, civilization imagines progress as a continuous expansion of knowledge. But cosmology introduces a universe where certain forms of knowledge decay permanently. The cosmos itself becomes less observable as it ages. Future intelligence may inherit less evidence than humanity possesses now. In this sense, modern civilization occupies a strange and fleeting observational window late enough for complex life to emerge, yet early enough for the larger cosmic structure still to remain partially visible. Humanity may exist during one of the few eras in which the universe can meaningfully study itself, and even now, the picture remains catastrophically incomplete. Dark matter still has no confirmed particle identity. Dark energy remains profoundly mysterious. Quantum gravity lacks a finished theory. Inflation explains observations elegantly but rests upon mechanisms still uncertain. Black hole information paradoxes remain unresolved. At the foundation of cosmology lies extraordinary predictive success balanced atop deep conceptual instability. Scientists can map the age of the universe with astonishing precision, while remaining uncertain what most of the universe actually is. This contradiction gives modern cosmology its uniquely haunting emotional tone. The universe is understandable enough to reveal its vastness, but not understandable enough to feel safe inside, and the scale of hidden reality may continue expanding indefinitely. Already, observations hint that the observable universe may be spatially flat on enormous scales. If true, this could imply the larger cosmos extends infinitely beyond observation. Not metaphorically infinite, literally, an endless expanse of regions forever beyond human contact. Infinite stars, infinite galaxies, infinite histories, possibly infinite versions of matter arranged in every physically allowed configuration. In such models, somewhere unimaginably distant, atoms may accidentally repeat patterns identical to Earth. Entire human histories could recur statistically across infinite space. Not because of destiny, because infinity eventually exhausts possibility. The emotional consequences are difficult to stabilize. Individual human lives begin feeling microscopically temporary against cosmic scale. Civilizations appear fragile. Biological memory becomes almost irrelevant compared to deep time. Even galaxies themselves drift like brief weather patterns across an incomprehensible background. And yet, paradoxically, awareness becomes more precious under these conditions, not less. Because consciousness may represent one of the rare structures capable of perceiving the universe at all. A temporary arrangement of matter through which reality becomes self-aware for a brief moment before dissolving again. The observable universe therefore contains a strange duality. It is vast enough to annihilate ordinary human perspective, yet perhaps still small enough for awareness to emerge locally inside it. Beyond the observable horizon, reality may continue forever without witness, without memory, without meaning, and this possibility introduces a deeper loneliness than empty space alone ever could. There is a point in cosmology where the universe stops feeling like a place. The transition happens gradually. At first, space appears navigable. Stars resemble destinations. galaxies resemble distant territories. Even enormous scales preserve a faint emotional connection to geography. But eventually the distances become so extreme that location itself begins losing meaning. Reality transforms into structure without intimacy. And this is where the observable universe becomes genuinely frightening. Because the deeper inflationary models are explored, the more the cosmos resembles something fundamentally beyond human psychological capacity. Not merely large, uncontainable. Modern cosmology increasingly suggests that the observable universe may be only a microscopic fluctuation inside an eternally expanding background beyond direct observation. Inflation, once initiated, may continue indefinitely across enormous regions of space-time, generating isolated pockets where local universes emerge like bubbles forming in boiling water. But even this analogy is too small, too comforting. Human beings instinctively imagine bubbles inside containers, oceans inside boundaries, processes occurring somewhere comprehensible. Yet eternal inflation may possess no external edge, no surrounding room, no larger emptiness into which it expands. Reality may simply generate itself endlessly, and every observable universe may exist inside its own disconnected causal island. The numbers become emotionally unusable almost immediately. If inflation continued for even modestly longer than required to explain current observations, the total cosmos beyond visibility would exceed the observable universe by factors so enormous that ordinary exponential notation becomes absurdly insufficient. Not billions of times larger, not trillions, numbers with more digits than atoms inside observable space itself. Entire expanses so vast that human language loses all functional relationship to quantity. And somewhere inside this unimaginable structure floats the thin sphere of ancient light humanity calls the observable universe. A local patch, a temporary condition, perhaps one among endless others. This realization changes the emotional meaning of astronomy permanently, because humanity no longer appears isolated merely within space. Humanity appears isolated within possibility itself. Entire regions of existence may remain forever disconnected, not due to technological limitation, but because space-time expansion physically prevents interaction. Even light cannot cross the inflationary gulf separating cosmic domains. There may be other universes existing right now beyond the observable horizon, each carrying its own history, physics, stars, and silence. And no evidence from them may ever arrive here. The separation is absolute, not difficult, absolute. This is psychologically devastating because human cognition evolved assuming continuity. The brain expects reality to connect smoothly beyond visible boundaries. Mountains continue past the horizon. Oceans remain physically reachable. Unknown lands eventually become known. Eternal inflation destroys this instinct completely. Reality may not be globally connected at all. Instead, existence could consist of disconnected causal fragments embedded inside a deeper structure too large for meaningful coherence. And the observable universe may represent one fragile oasis where conditions temporarily permit complexity. The deeper implication emerges slowly. If inflation generates universes continuously across unimaginable durations, then almost every possible arrangement of matter permitted by physics may eventually occur somewhere, not through intention, through statistical inevitability. This possibility introduces one of the strangest consequences in modern cosmology Boltzmann brains. The idea sounds absurd at first, but its logic emerges naturally from thermodynamics and infinite timescales. In sufficiently large or eternal systems, random fluctuations become unavoidable. Given enough time, particles occasionally arrange themselves into temporary ordered states. Most fluctuations are tiny and meaningless, but across incomprehensible durations, larger fluctuations become statistically inevitable, including theoretically self-aware observers. A conscious mind could briefly emerge spontaneously from chaos, complete with artificial memories and perceptions, before dissolving again into disorder. A single isolated awareness appearing momentarily inside thermal randomness. The idea horrifies physicists not because they believe Boltzmann brains literally populate the cosmos in ordinary numbers, but because some cosmological models accidentally predict they would vastly outnumber biological observers like humans. And if that were true, statistical reasoning produces a deeply disturbing conclusion. The typical observer in the universe would not be a civilization evolving across billions of years. It would be an isolated consciousness hallucinating reality briefly before vanishing. This is where cosmology begins intersecting existential horror directly. Not cinematic horror, not monsters. The horror of unstable reality, of uncertain observation, of existing inside systems too vast for verification. Modern cosmology repeatedly generates these moments where scientific reasoning approaches conclusions emotionally incompatible with ordinary human experience. And the universe remains indifferent throughout. The observable universe does not care whether its structure feels psychologically survivable. It simply exists. The stars continue burning, galaxies continue separating, dark energy continues stretching space-time toward increasing isolation. Meanwhile, the scale of the unseen cosmos may continue expanding toward infinity. Some physicists attempt to avoid these implications through alternative models. Others argue eternal inflation remains incomplete or incorrect. Debate continues intensely because observational confirmation becomes extraordinarily difficult once theories extend beyond causal accessibility. This creates another profound problem. Science traditionally relies upon testability, but what happens when the largest implications of cosmology concern regions forever beyond observation? Can something remain scientifically meaningful if direct evidence can never arrive? The observable universe imposes brutal constraints here. Information from beyond the cosmic horizon cannot reach Earth. Entire classes of theories, therefore, operate near the edge of empirical science itself, mathematically rigorous, internally consistent, partially supported indirectly, yet permanently isolated from direct confirmation. Humanity encounters a boundary not only in space, but in epistemology, a limit to what observation can verify. This does not make the theories arbitrary. Inflationary cosmology explains many measured properties of the universe with remarkable success. But it does reveal something unsettling about human knowledge. There may exist true descriptions of reality that no civilization can ever fully confirm experimentally. Reality itself may exceed the observable capacity of intelligence, and this changes the emotional role of the night sky. For most of history, the stars inspired orientation, navigation, mythology, stability. Even after scientific revolutions, space still felt materially connected to human existence. The cosmos remained a single shared environment, but inflationary cosmology dissolves that continuity. The observable universe becomes less like a homeland and more like a temporary illuminated chamber suspended inside an incomprehensible structure extending forever beyond contact. The stars overhead cease feeling permanent. They become local. Provincial, tiny thermonuclear lights scattered through one microscopic region of one causally isolated bubble among perhaps endless others, and somewhere beyond the observable horizon, space-time may continue inflating eternally into darkness so immense that even entire universes become negligible fluctuations within it. Human language reaches its limit here, because words like outside, beyond, and larger still imply relationships grounded in ordinary geometry. But the inflationary cosmos may transcend ordinary spatial intuition entirely. Reality may not possess a final edge. No outer wall, no surrounding void, no ultimate center, only endless structure generating further structure beyond visibility forever. And inside one brief region of this immense process, on a cooling planet orbiting an ordinary star, biological matter evolved enough self-awareness to glimpse the scale surrounding it. Only partially, only temporarily, like deep-sea organisms sensing the existence of an ocean they can never fully perceive. The observable universe may therefore represent not the whole of reality, but merely the thin illuminated layer through which reality accidentally became visible to itself for a moment. And beyond that layer, existence continues silently outward into distances so extreme that even imagination begins to fail. Human civilization was not designed for cosmic truth. The evidence for this appears everywhere. Language evolved to describe nearby objects moving at biological speeds. Memory evolved for survival across decades, not billions of years. Human emotions calibrate naturally to families, tribes, landscapes, storms, seasons, not galaxies, certainly not the observable universe. And yet modern cosmology forces the human mind into direct confrontation with scales that systematically dismantle instinctive understanding. This is why the emotional impact of astronomy often arrives slowly. The facts themselves can be learned quickly. Distances, expansion, black holes, cosmic horizons. These concepts become familiar through repetition. But familiarity is not comprehension. The deeper psychological consequences take longer to unfold, because once the observable universe is viewed honestly, human civilization begins shrinking in unsettling ways. Earth already feels fragile from orbit. Astronauts repeatedly describe the same experience after leaving the atmosphere. Borders vanish, cities disappear, political conflicts become invisible. The planet appears small, luminous, temporary against surrounding darkness. The overview effect, but cosmology extends this realization much further. Earth is not merely a small planet, it is a transient chemical surface layer orbiting one medium-sized star inside a galaxy containing hundreds of billions more. The Sun itself formed relatively late in cosmic history, from the remains of older stars that died before Earth existed. Every atom heavier than hydrogen inside the human body was forged through ancient stellar collapse. Human biology is assembled from stellar debris. Even this statement, repeated often enough, conceals its emotional weight. The atoms inside your blood may once have drifted through exploded stars billions of years before Earth formed. Matter circulates continuously through cosmic history without memory of previous forms. Civilization emerged recently from this process. Extremely recently, if the age of the observable universe were compressed into one calendar year, all of recorded human history would occupy only the final seconds before midnight on December 31st. Agriculture, cities, empires, science, religion, industrialization, digital technology all would unfold almost instantaneously at the very end of cosmic time. Everything humans consider ancient becomes cosmologically microscopic. The pyramids are recent. Dinosaurs are recent. Even galaxies themselves were already old when Earth formed. This temporal scale quietly destabilizes human significance because civilization instinctively measures importance through historical duration. Nations feel permanent because human memory is short. Languages feel ancient because biology is brief. Cosmology exposes these assumptions as local illusions. The observable universe operated for billions of years before humanity appeared, and it will continue long after humanity disappears. This is not philosophical pessimism. It is thermodynamic reality. Stars consume finite fuel. Biological species emerge and vanish. Civilizations rise under temporary environmental conditions. Extinction remains the default outcome for almost every life form Earth has ever produced. Humanity exists inside this same process. The universe is not hostile in the emotional sense, only indifferent, and indifference at cosmic scale becomes psychologically difficult to process because human beings evolved expecting meaning to emerge from response. Social existence depends upon recognition. Suffering matters because other minds perceive it. Human morality assumes local significance, but the observable universe does not respond. Galaxies drift silently regardless of human triumph or catastrophe. Black holes consume stars without intention. Cosmic expansion accelerates independently of civilization's survival. The universe permits meaning locally while remaining globally indifferent to it. This creates one of the deepest emotional tensions in modern cosmology. Human consciousness experiences itself as central from the inside. Every memory, fear, relationship, and ambition feels enormous within subjective awareness. Yet externally, the entire history of human civilization occupies a nearly undetectable region of space-time. Both perspectives are true simultaneously, and the brain struggles to hold them together. This struggle intensifies when considering future cosmic time. The Sun currently sits roughly halfway through its stable lifespan. In about 5 billion years, hydrogen fusion in its core will fail gradually. The star will expand into a red giant large enough to consume or sterilize the inner planets. Earth's biosphere will disappear long before this final stage arrives. The oceans will evaporate, the atmosphere will destabilize, surface life will vanish. Every human monument, language, archive, photograph, and memory will eventually be erased by stellar evolution alone. Even if civilization survives technologically elsewhere, Earth itself remains temporary. And beyond the solar system, larger cosmic processes continue unfolding with equal indifference. Galaxies collide slowly over billions of years. Black holes merge, stars die. Dark energy stretches the universe toward increasing isolation. Eventually, star formation itself may cease as available gas becomes exhausted. The cosmos grows quieter over time, less structured, less luminous. Modern physics predicts several possible long-term fates for the universe. None are emotionally comforting. In the heat-death scenario, expansion continues indefinitely until galaxies separate beyond visibility. Stars extinguish, and matter decays toward near-uniform entropy across unimaginable durations. Reality approaches thermodynamic exhaustion, a thin, cold darkness where usable energy becomes increasingly rare. Other models propose vacuum decay, where the underlying quantum structure of space-time may be metastable. A transition to a lower-energy vacuum state could propagate outward at light speed, rewriting physics itself instantly across entire regions of the universe. No warning, no defense, no memory afterward. Even if such events are extraordinarily unlikely, cosmology increasingly reveals that existence rests atop processes vastly larger and stranger than biological intuition can emotionally accommodate. This is why the observable universe eventually begins feeling less like a home and more like an environment temporarily permitting awareness before returning to silence. Human civilization occupies a narrow thermal window between primordial chaos and cosmic exhaustion. A brief interval where stars burn steadily enough for chemistry to organize into life, and this interval may be exceptionally fragile. The deeper scientists examine planetary history, evolutionary history, and cosmic history together. The more contingency appears everywhere. Mass extinctions repeatedly reshaped Earth's biosphere. Asteroid impacts altered evolutionary trajectories. Climatic instability nearly eliminated complex ecosystems multiple times. Human existence depends upon countless accidents aligning across billions of years, not destiny, accumulated improbability. And perhaps this fragility explains why cosmic scale affects the human mind so powerfully. The observable universe reveals not only vastness, but conditionality. Civilization no longer appears inevitable. Consciousness no longer appears central. Human permanence dissolves. Yet paradoxically, awareness becomes more emotionally intense under these conditions, because fragile things acquire a different kind of significance. A candle burning briefly inside immense darkness does not become less beautiful, because the darkness is large. If anything, the contrast deepens it. This may be why astronomy produces both existential fear and profound calm simultaneously. The universe removes humanity from the center, while also revealing participation in something unimaginably larger. Every human being is composed of ancient cosmic matter temporally capable of reflection. The observable universe became conscious locally through biological evolution on at least one planet. Perhaps others, perhaps many others, or perhaps almost nowhere. The silence of the cosmos remains unresolved. And the silence matters because it reinforces another unsettling possibility. The observable universe may contain vast regions permanently empty of awareness entirely. Galaxies may drift through darkness for billions of years without producing consciousness at all. Entire cosmic epochs may unfold unwitnessed. Human civilization therefore occupies a peculiar position, tiny enough to vanish inside cosmic scale, yet possibly rare enough to matter because of that very scale. A temporary concentration of awareness surrounded by incomprehensible distances, and beyond the observer's perceptual horizon, the darkness continues expanding outward forever. The observable universe feels immense only until cosmology places it inside larger systems. Then, once again, scale collapses beneath something deeper. This pattern repeats relentlessly throughout astronomy. Every time humanity believes it has approached the outer structure of reality, the boundary dissolves into a wider framework beyond it. Earth became one planet among many. The solar system became one stellar system. The Milky Way became one galaxy. The observable universe itself may now be only one local region inside something far larger. And the unsettling part is not merely the expansion of size, it is the expansion of context. Because context changes meaning. A single human life feels substantial within personal experience. Humanity feels historically important within civilization. Earth feels vast from the surface. Yet each layer shrinks dramatically once embedded inside a larger structure. Cosmology increasingly applies this same humiliation to the universe itself. The observable universe may not be the stage upon which reality exists, only one visible chamber inside a deeper architecture. This possibility emerges partly from inflationary theory, partly from quantum cosmology, and partly from a disturbing mathematical fact: many of the most successful physical theories naturally generate realities larger than direct observation permits. The equations continue beyond visibility, and scientists are forced to decide whether those invisible implications should be taken seriously. Some of the most radical models suggest space-time itself may exist inside higher dimensional frameworks inaccessible to ordinary perception. Human beings experience 3 spatial dimensions and 1 temporal dimension because biology evolved within those conditions. But mathematics describing gravity and quantum fields often behaves more naturally in systems containing additional dimensions, folded beyond direct detection. The idea sounds abstract until its emotional implications become clear. Reality may possess structural directions entirely invisible to human experience. Not hidden far away, hidden everywhere. A useful comparison is a 2-dimensional organism living on the surface of paper. Such a being could move left, right, forward, and backward, while remaining permanently incapable of perceiving up. Entire layers of existence might intersect its world invisibly without violating any local physical law. Modern theoretical physics cautiously entertains the possibility that humanity occupies something similar, a local slice of deeper structure. This does not mean science has proven extra dimensions exist. It has not. But several major frameworks attempting to unify gravity and quantum mechanics naturally produce them mathematically. And once again, the observable universe begins shrinking conceptually. Because if space-time itself belongs to a larger system, then the visible cosmos may resemble only the exposed surface of a far deeper reality. Some brain cosmology models propose that universes could exist like membranes floating inside higher dimensional space. Gravity may leak weakly between these structures while other forces remain trapped locally. Entire universes might drift beside ours invisibly, separated by dimensions rather than ordinary distance. The emotional effect is strangely claustrophobic. The observable universe stops feeling isolated within emptiness and starts feeling embedded within unseen architecture, not alone, but inaccessible. And this is where cosmology becomes psychologically disorienting, because ordinary human intuition relies heavily on visual continuity. People assume reality resembles what can be pictured mentally. But the deeper theoretical physics advances, the less reality appears compatible with visualization at all. Quantum fields fluctuate invisibly beneath matter. Dark matter surrounds galaxies without emitting light. Dark energy drives expansion through unknown mechanisms. Possible higher dimensions evade sensory perception entirely. The observable universe increasingly resembles a thin, visible layer suspended atop hidden systems humans infer mathematically but cannot directly experience. This transformation has altered the philosophy of science profoundly. Classical physics once promised intuitive order. Planets orbited predictably. Forces behaved mechanically. The cosmos resembled an enormous clock. Modern cosmology instead reveals a universe governed by structures fundamentally alien to biological perception, and still the implications continue expanding. One especially unsettling possibility arises from holographic principles in theoretical physics. Certain formulations suggest that the information describing a region of space may actually reside on lower dimensional boundaries surrounding it. In simplified terms, reality may function less like solid volume and more like encoded information projected into experiential form. The idea remains deeply theoretical and controversial in interpretation. Yet its mathematical foundations emerged from attempts to resolve black hole paradoxes involving entropy and information conservation. Again, black holes appear at the center of the crisis, because black holes force physics into confrontation with its own incompleteness. Matter falls inward. Information appears trapped behind horizons. Quantum theory insists information cannot simply vanish. Relativity predicts gravitational collapse towards singularities. The equations strain against each other. And increasingly, many physicists suspect space-time itself may not be fundamental. It may emerge from deeper informational relationships not yet fully understood. This changes the emotional meaning of the observable universe completely. Reality begins resembling something less material and more structural, a temporary manifestation arising from underlying laws humans barely comprehend. The stars overhead remain physically real, but the framework generating them becomes increasingly mysterious. And the larger the framework grows, the smaller local existence appears within it. This scaling effect creates a subtle existential pressure throughout cosmology. Human beings evolved expecting reality to possess stable middle scales, large enough to explore, small enough to imagine, but modern science continuously destroys middle scale. Atoms dissolve into quantum uncertainty below. Galaxies dissolve into inflationary vastness above. Humanity exists suspended between infinities, too large to perceive quantum structure directly, too small to perceive cosmic structure fully, trapped in an intermediate biological perspective incapable of accessing either extreme comfortably, and yet science continues extending awareness beyond those biological limits through mathematics and instrumentation. This is perhaps the strangest achievement of civilization. A species evolved for hunting, fear, reproduction, and survival somehow learned to detect microwave radiation from the early universe, measure gravitational distortions from invisible matter, and infer the existence of structures beyond direct observation entirely. The universe became conscious enough locally to study its own architecture, but the architecture itself may exceed complete understanding permanently. This possibility grows more severe when considering computational limits. Even if human intelligence advances indefinitely, physical systems constrain what can actually be known or simulated. Information density, energy availability, entropy, and cosmic horizons impose hard boundaries on computation itself. Some regions of reality may therefore remain inaccessible not only observationally, but mathematically. Too complex, too distant, too causally disconnected. There may be truths no civilization can fully model because the universe physically prevents sufficient information gathering. This is a profound reversal of Enlightenment optimism. The dream of total knowledge collapses beneath cosmological scale, not because science failed, because science succeeded far enough to discover the limits built into reality itself. And still, beyond every discovered limit, the structure appears to continue outward, perhaps infinitely. The observable universe therefore occupies a strange emotional position. It feels unimaginably vast from human perspective. Yet within modern cosmology, It may represent only one local domain among structures so much larger that even galaxies become granular details inside them, a visible bubble inside deeper architecture. A temporary region where laws stabilized enough for stars and awareness to emerge. A thin, illuminated layer floating within systems still mostly hidden, and somewhere beyond all observable horizons, beyond inflationary separation, beyond dimensional speculation and quantum uncertainty, reality continues existing without needing to be seen. The universe does not require observation to remain real. It expands beyond witness, beyond memory, beyond comprehension, and humanity, suspended briefly within one small observable region, can only infer the larger structure indirectly through fragments of ancient light arriving across darkness older than civilization itself. Silence is one of the defining features of the universe. Not metaphorically, physically. Space carries no sound across its vacuum. Stars burn noiselessly. Galaxies collide without thunder. Supernovae release energies so immense they briefly outshine entire galaxies. Yet across interstellar distances the explosions unfold in perfect silence. Human beings were not built for this kind of environment. Every ancestral landscape on Earth contained noise wind through trees, rainfall, predators moving in darkness, oceans striking coastlines. Sound signaled proximity, danger, survival. Silence usually meant something temporary. The cosmos reveals a different kind of silence entirely. Permanent silence, and the farther astronomy expands human awareness, the more overwhelming that silence becomes. The observable universe contains perhaps trillions of galaxies. Each galaxy contains billions of stars. Around many of those stars orbit planets older than Earth. Some planets may possess oceans, atmospheres, chemistry, stability extending across immense periods of time. Statistically, the conditions for life seem widespread, and yet the universe remains quiet. No confirmed signals, no verified civilizations, no evidence of technological activity crossing interstellar distances. This contradiction has haunted cosmology for decades. Enrico Fermi expressed it simply in 1950 during a casual lunch conversation. Where is everybody? The question sounds almost naive initially, but its implications deepen the longer one considers cosmic timescales. The Milky Way is ancient. Even modestly advanced civilizations capable of interstellar expansion could theoretically spread across the galaxy within periods short compared to cosmic history, perhaps millions of years, perhaps tens of millions. Cosmologically, this is brief. If intelligent life emerges commonly, the galaxy should already display visible signs of ancient activity. Yet observation reveals nothing conclusive, only stars. Only silence. This absence has generated countless proposed explanations. Intelligent life may be extraordinarily rare. Civilizations may destroy themselves quickly. Technological species may lose interest in expansion. Communication across cosmic distances may prove impractical. Biological consciousness itself may represent an unstable evolutionary accident. Or perhaps advanced civilizations exist but remain undetectable to humanity's primitive observational methods. No explanation currently resolves the paradox cleanly, and the emotional effect is difficult to escape, because the observable universe increasingly appears vast enough for life to exist elsewhere, yet silent enough to imply profound isolation. The loneliness becomes heavier when combined with cosmic expansion, even if intelligent civilizations exist across distant galaxies. The accelerating universe gradually prevents meaningful interaction between large-scale structures. Entire galaxies are already receding beyond future contact. Over trillions of years, surviving civilizations may become imprisoned within isolated gravitational islands surrounded by unreachable darkness. The universe separates observers naturally, not through hostility. Through geometry, this creates one of the strangest possibilities in cosmology. There may be intelligent species existing right now beyond the observable horizon, asking identical questions beneath alien skies, while absolute physical barriers prevent either civilization from ever discovering the other. Not because communication failed, because space-time itself forbids contact. The tragedy is mathematical, and perhaps this isolation extends deeper still. Some physicists have speculated that even the observable universe may be unusually empty compared to other regions of a larger multiverse. Others suggest life could cluster only during narrow cosmological windows when stars, heavy elements, and stable environments briefly align. Consciousness may therefore represent not the natural outcome of cosmic evolution, but a temporary anomaly occurring rarely against immense background emptiness. The observable universe then changes emotional character again. It stops resembling a populated frontier and begins resembling a scattered archipelago of brief awareness floating through overwhelming darkness. This darkness is not merely spatial, it is temporal. The future universe appears increasingly hostile to complexity. Star formation already proceeds more slowly than in the past. Galaxies gradually consume or lose the gas required for new stars over enormous timescales. Stellar populations age and dim. The cosmos enters what physicists call the degenerate era, a distant epoch dominated by cooling remnants, white dwarfs, neutron stars, black holes. The bright universe humans inhabit today is temporary. Civilization emerged during one of the cosmos's most luminous periods. A relatively early era when stars still burn abundantly and galaxies remain visible across deep space. Future epochs may become unimaginably darker. Imagine standing beneath a sky where nearly all galaxies have vanished beyond cosmic expansion. No glowing spiral structures fill the heavens. No evidence of the Big Bang remains detectable. Only a few surviving stellar remnants orbit inside one merged galactic system surrounded by black emptiness. Future astronomers may inherit a universe stripped of its own history. This possibility profoundly unsettles cosmologists because it reveals how temporary observational truth may be. Humanity currently sees evidence future civilizations might never access. The observable universe is fading even now. Not dramatically, gradually, quietly, and eventually the silence deepens further. Black holes, once considered eternal, may themselves evaporate over impossible durations through Hawking radiation. Quantum effects near event horizons slowly drain their mass across timescales so vast that ordinary language collapses trying to describe them. A supermassive black hole may require more years to evaporate than there are atoms in observable space. Yet eventually even they disappear. Matter decays, stars extinguish, galaxies dissolve. The universe trends towards lower energy, lower structure, lower complexity, towards silence, toward thermal equilibrium, and beyond the observable horizon, the same processes unfold invisibly in regions forever inaccessible to Earth. Entire cosmic histories may rise and vanish unwitnessed. This realization produces a subtle existential inversion. Human beings often fear being observed, judged by gods, civilizations, history, or future generations. But cosmology increasingly suggests the opposite condition. Most of reality may unfold without witness entirely. The observable universe could contain enormous regions where consciousness never emerges at all. Vast, dark expanses may drift through cosmic time permanently unobserved. In this context, awareness becomes strangely fragile. Every conscious experience represents a temporary local interruption in cosmic silence, a biological process through which matter briefly acquires memory and perception before dissolving again. And perhaps this is why the night sky affects humans so deeply. Not because the universe appears full, because it appears mostly empty. The stars stand out precisely because darkness dominates everything surrounding them. The observable universe therefore presents a terrifying contrast between rarity and scale, rare islands of structure, rare intervals of biological awareness, rare moments where intelligence studies the cosmos before extinction reclaims it. Against this background, human civilization begins feeling less like the center of history and more like a brief signal flare inside enormous darkness. And still the silence continues. Radio telescopes sweep the heavens. Optical observatories map distant galaxies. Infrared instruments search for unusual thermal signatures. Scientists analyze exoplanet atmospheres for traces of biology. The universe answers with ancient light and gravitational patterns, but not with voices, not with evidence of neighbouring minds. Only expanding emptiness, only stars burning temporarily against night, and beyond the observable universe the silence deepens further into regions no signal from Earth will ever reach. Reality continues there without memory of humanity, without acknowledgement and without witness, an endless darkness expanding beyond the final limits of observation itself. At some point, the scientific details stop arriving merely as information. They begin changing the emotional atmosphere of existence itself. The observable universe does this slowly, not through sudden revelation, but through accumulation. Distances grow larger, timelines grow older, human history becomes thinner against expanding cosmic context. Eventually, without noticing exactly when it happened, the mind stops experiencing the universe as a familiar environment. Reality becomes something stranger, colder, or structurally indifferent, and yet many people describe this realization not as despair, but as a peculiar form of peace. This contradiction sits at the center of cosmic perspective, because the universe simultaneously diminishes human importance and relieves humanity of certain illusions. Most daily anxieties evolved for local survival: reputation, competition, fear of exclusion, fear of failure. The human nervous system remains calibrated for tribal existence inside small groups where social standing could determine life or death. Cosmology quietly destabilizes these scales. Civilization itself becomes temporary against deep time. Entire nations vanish almost instantly compared to stellar evolution. Human conflicts, however emotionally overwhelming locally, disappear within cosmic chronology. This does not make suffering unreal. It changes proportion. The observable universe introduces a perspective so enormous that ordinary human narratives become difficult to sustain with previous intensity. And perhaps this is why astronomy often feels emotionally cleansing. Not because the cosmos is comforting, but because it is honest about scale. The stars do not flatter humanity. The universe offers no evidence that consciousness occupies a privileged position. Galaxies existed long before humans appeared. They will continue evolving after humanity disappears. The cosmos does not reorganize itself around human emotion. At first this feels unsettling. Then, for many people, strangely liberating. Because meaning no longer depends upon cosmic centrality. A sunset remains beautiful even though the sun is ordinary among stars. Love remains emotionally real even though biology emerged accidentally. Human memory remains precious even though civilization is temporary. Cosmology removes permanence without removing experience, and this creates a quieter philosophy than most ancient systems allowed. Human beings do not need to stand at the center of reality for awareness to matter locally. A brief conscious life inside an immense universe may still contain depth precisely because it is brief. The observable universe reinforces this lesson repeatedly. Stars burn finite fuel, planets cool, species vanish, galaxies drift apart. Impermanence is not the exception within cosmic history. It is the rule. Even the night sky changes across geological time. Constellations slowly deform as stars move through the galaxy. Future humans, if humanity survives long enough, will inherit unfamiliar skies. Entire celestial patterns that guided ancient civilizations will eventually dissolve. The heavens themselves are temporary arrangements, and beyond the observable horizon, this transformation continues invisibly forever. The emotional pressure of cosmology, therefore, comes not only from vastness, but from instability. Reality is not static architecture suspended eternally in perfect order. It is process unfolding continuously across scales, beyond intuition. Human civilization occupies one moment inside that unfolding, a very small one, yet perhaps awareness changes the meaning of scale itself. Because although the observable universe may not care about humanity, humanity cares about the observable universe. Matter arranged into conscious systems developed curiosity intense enough to study stars, reconstruct cosmic history, and ask questions extending beyond observational limits. The universe became self-reflective locally. This remains one of the strangest facts in existence. Across billions of years of stellar evolution and planetary chemistry, atoms eventually organized themselves into structures capable of wondering what lies beyond the observable horizon. Hydrogen produced philosophy. Nuclear fusion produced memory. Ancient stellar debris learned to experience awe, and awe itself may represent an important response to cosmic truth. Not because awe solves existential uncertainty, but because it acknowledges it honestly. Many traditional worldviews attempted to reduce uncertainty by placing humanity inside clear narratives, divine plans, cosmic hierarchies, eternal destinies. Modern cosmology dissolves many of these structures without necessarily replacing them. The observable universe offers scale instead of reassurance, silence instead of certainty, immensity instead of permanence. Yet human beings continue searching the darkness anyway. This persistence reveals something profound about consciousness. The universe may be indifferent, but awareness resists indifference instinctively. Humans continue asking questions even when final answers appear unreachable. Perhaps because questioning itself becomes meaningful, not cosmically meaningful in some absolute sense, but experientially meaningful. A civilization studying the universe participates in reality differently from one ignoring it. Curiosity alters consciousness. Cosmic perspective reshapes emotional proportion. The observable universe changes the minds capable of perceiving it. This may explain why astronauts often return from space psychologically transformed. Seeing Earth suspended against cosmic darkness disrupts ordinary assumptions permanently. Problems once experienced as enormous suddenly feel local. Borders appear artificial. Human fragility becomes undeniable. The overview effect is not merely visual, it is philosophical compression, and cosmology extends this compression across all scales simultaneously. Humanity becomes smaller, the universe becomes larger, yet awareness becomes more precious because of that contrast. A single conscious moment occurring inside billions of years of cosmic silence acquires unusual emotional intensity. Not eternal intensity, temporary intensity. The observable universe therefore produces a philosophy closer to humility than despair. Reality existed before humanity. Reality will continue after humanity. Most of reality may remain forever inaccessible to humanity. And still, for one brief interval, the cosmos became observable from within. This thought carries a strange tenderness beneath its enormity. The stars overhead are ancient thermonuclear systems indifferent to human existence. Yet human minds transformed those distant lights into mathematics, navigation, myth, science, poetry, and reflection. The universe did not assign meaning to itself. Consciousness generated meaning locally through experience. And perhaps this is enough. Not enough to eliminate mortality, not enough to resolve cosmological uncertainty, not enough to prevent extinction, but enough to make awareness remarkable, because against the backdrop of cosmic scale, conscious life appears increasingly rare, fragile, and temporary. The observable universe may contain vast expanses where no minds ever emerge at all. Entire galaxies may drift through darkness unwitnessed for billions of years. Yet here, on one planet orbiting one ordinary star, reality learned briefly to examine itself, to ask what lies beyond observation, to feel fear before immensity, wonder before silence, calm before deep time. And perhaps the observable universe changes human beings most profoundly not by answering questions, but by teaching proportion. Every civilization eventually confronts limits of lifespan, limits of memory, limits of understanding. Cosmology simply reveals those limits at the largest possible scale. Beyond the observable horizon, reality continues without needing human comprehension. The universe does not pause for observation. It expands into darkness regardless of whether consciousness survives long enough to study it. And yet tonight, beneath a thin atmosphere on a cooling planet, human beings still look upward, still measure ancient light, still build instruments against the dark, still ask questions larger than themselves. A temporary species inside a temporary civilization examining a temporary visible region of a universe that may extend forever beyond sight. And there is something quietly beautiful in that. The observable universe may not be the greatest limit humanity faces. The deeper limit may be knowledge itself. This possibility emerges slowly from cosmology, almost reluctantly, as though science discovered it accidentally while searching for something else. For centuries, intellectual progress created the impression that reality would eventually yield to persistence. Mystery shrank under observation. Ignorance retreated before mathematics and experiment. Then cosmology reached scales where observation itself began failing, and beyond those failures waits a final unsettling implication. There may exist truths about existence that no civilization, no matter how advanced, can ever access. Not because intelligence is weak, because the universe is structured in ways that permanently restrict information. The observable universe already demonstrates this principle clearly. Light travels at finite speed. Cosmic expansion isolates distant regions. Horizons conceal events permanently. Entire domains of reality remain causally disconnected forever. But these may be only the first limitations. Modern physics increasingly suggests that incompleteness is woven directly into reality at multiple levels simultaneously. Quantum mechanics imposes uncertainty. Relativity imposes causal separation. Thermodynamics imposes entropy. Black holes impose information barriers. Every foundational theory contains limits, and the limits overlap. This convergence has forced physicists into a disturbing realization the universe may not merely be difficult to fully understand, it may be physically impossible to fully understand. One of the clearest examples appears through Gödel-like incompleteness emerging conceptually inside mathematics and computation. Any sufficiently powerful formal system contains truths that cannot be proven within the system itself. Computation faces similar restrictions. Certain problems become fundamentally undecidable regardless of processing power. Human civilization once imagined enough intelligence could eventually solve everything. Modern logic quietly dismantled that hope, and cosmology amplifies the problem enormously, because the universe itself may operate as a system too large and internally constrained for complete self-description. Reality studying itself from within may encounter permanent blind spots. Human beings are embedded observers, not external analysts. Every experiment, telescope, equation, and theory emerges from inside the observable universe using finite matter, finite energy, finite time, and incomplete access to information. Civilization is attempting to reconstruct total reality from one local fragment. This may never be enough. The emotional significance of this realization is difficult to overstate. For most of history, mystery implied temporary absence of knowledge. But cosmology introduces mystery as structural inevitability. Certain answers may not exist in accessible form, and this transforms the observable universe into something more psychologically unsettling than mere vastness. It becomes a boundary of epistemological isolation. Humanity may inhabit a cosmos whose full architecture can never be seen from any internal perspective. No final map, no complete view from outside, no ultimate frame revealing total structure, only local windows, only partial reconstructions assembled from ancient light and mathematical inference. This problem intensifies dramatically near black holes. Black holes are not simply dense objects. They are regions where space-time itself becomes so curved that causal structure breaks away from ordinary intuition. The event horizon functions like a one-way membrane. Information crosses inward but cannot return outward conventionally. Stephen Hawking's discovery that black holes radiate quantum energy complicated matters further. If black holes eventually evaporate completely, what happens to the information contained inside them? Quantum theory forbids total information destruction. Relativity permits horizons concealing information permanently. The resulting contradiction, the black hole information paradox, remains unresolved despite decades of effort from the world's greatest physicists. This matters because black holes may expose fundamental limits of space-time description itself. Some researchers suspect space-time emerges from deeper quantum informational processes still poorly understood. Others believe gravity and quantum mechanics require radical reformulation together, but no consensus exists. And the deeper scientists investigate, the stranger reality appears. Recent theoretical developments suggest space-time geometry may connect intimately to entanglement patterns between quantum systems. In some models, space itself arises from relationships between information rather than existing as a pre-built stage. If true, the observable universe becomes even more conceptually unstable. Reality may not fundamentally consist of objects moving through space. Space may itself be a secondary phenomenon emerging from deeper structures inaccessible to direct perception. Human intuition collapses completely here. The brain evolved to perceive solid objects inside continuous space progressing through time. Cosmology increasingly suggests all three intuitions may be incomplete approximations, and yet this may still represent only the visible layer of deeper incomprehensibility, because once knowledge encounters permanent limits, another terrifying possibility emerges naturally. What if the observable universe is not merely incomplete to human beings? What if incompleteness is universal? Even hypothetical superintelligent civilizations millions of years beyond humanity may still remain trapped inside causal horizons. Quantum uncertainty, entropy, and computational restriction. They too may confront unreachable truths. They too may mistake local conditions for universal structure. There may be no final observers in existence, only increasingly sophisticated local perspectives embedded inside systems too vast for completion. The universe may therefore remain fundamentally unresolved forever, not awaiting resolution, inherently unresolved, and this creates a profound emotional reversal. Human civilization often imagines cosmic progress culminating eventually in total understanding, a final theory unifying physics, consciousness, cosmology, and existence into coherent explanation. But the observable universe may instead reveal a cosmos where every layer of explanation exposes deeper unanswered structure beneath it indefinitely. An endless descent. The farther science travels, the larger the unknown becomes. This pattern has repeated relentlessly throughout modern cosmology. Each discovery expanded mystery faster than it reduced it. Galaxies revealed larger structure. Relativity revealed space-time curvature. Quantum mechanics revealed uncertainty. Inflation revealed possible multiverses. Dark matter revealed hidden mass. Dark energy revealed unknown expansion. Reality grows stranger under observation, not simpler. And perhaps this is the final existential implication hidden beyond the observable horizon. The universe may exceed not merely human scale, but the scale of coherent explanation itself. Existence may not converge toward final clarity, only toward deeper approximation. Meanwhile, the observable universe continues expanding outward beyond human reach. Galaxies fade, stars die, information becomes inaccessible, entropy increases, civilizations may rise and vanish while remaining forever ignorant of most reality surrounding them. And still, consciousness persists locally for brief intervals. Matter continues organizing itself into observers capable of confronting the darkness. However partially, temporary beings continue asking impossible questions despite knowing complete answers may never arrive. There is something deeply human in this resistance. The refusal to stop looking outward despite incomprehension. The refusal to surrender curiosity even when the observable universe reveals itself as a tiny illuminated fragment inside potentially endless hidden structure. Perhaps this is why cosmology affects people so profoundly. Not because it provides certainty, but because it strips certainty away honestly. The universe no longer appears designed around comfort, destiny, or intelligibility. It appears vast, cold, mathematically elegant, partially unknowable. And inside one local region of space-time, fragile biological minds became aware enough to recognize the limits surrounding them. The observable universe may therefore represent more than a cosmic boundary. It may represent the edge of what any mind can meaningfully possess. Beyond it lies not simply darkness, but inaccessible truth. A reality continuing forever outside the illuminated sphere of knowledge. And perhaps the final terror of cosmology is not that the universe is empty, but that it may be endless, incomprehensible, and ultimately indifferent whether it is ever fully understood at all. Eventually, the mind stops resisting the scale, not because it fully understands the universe, but because complete understanding no longer feels necessary. After enough time spent contemplating cosmic distances, ancient light, unreachable galaxies, and the invisible expansion of space-time, something quiet begins happening inside human perspective. The instinct to place oneself at the center weakens. Urgency softens slightly. Ordinary concerns lose some of their absolute weight. The observable universe remains enormous. Human life remains brief, but the emotional relationship between them changes. The night sky no longer feels hostile in the way it once did, only vast and profoundly indifferent. There is a strange calm hidden inside indifference. Storms on Earth feel frightening because they move toward us. Predators trigger fear because they intend harm. Human conflicts wound because minds oppose one another deliberately. But the cosmos does not aim itself at humanity. Galaxies are not cruel. Black holes are not malicious. Entropy is not angry. The universe simply unfolds according to structures far older than biology. And this realization slowly dissolves certain ancient fears while introducing quieter ones in their place. Fear of disappearance. Fear of impermanence. Fear that most of reality exists forever beyond reach. Yet even these fears begin changing character beneath deep time, because cosmology reveals that impermanence is not a flaw in existence. It is its natural condition. Stars are temporary, species are temporary, galaxies are temporary. Even the observable universe itself may represent only one brief phase inside larger structures continuing beyond visibility. Human beings often imagine permanence as stability and impermanence as tragedy. But the cosmos suggests something different. Change is not interrupting reality. Change is reality. The atoms inside every living organism circulate continuously through older systems. Carbon formed in ancient stars. Oxygen emerged through stellar fusion long before Earth existed. Matter reorganizes itself endlessly across cosmic history. Nothing truly remains. Nothing truly disappears. Structure dissolves and reforms. And perhaps consciousness belongs to this process too. A temporary pattern through which the universe becomes aware locally for a brief interval before returning to silence. There is melancholy in this thought, but also relief, because if awareness itself is temporary, then uncertainty becomes unavoidable rather than personal failure. Humanity does not stand outside the universe trying unsuccessfully to comprehend it. Humanity is part of the universe, emerging from the same physical processes it studies, the observable universe examining itself through biological minds. Only partially, only briefly. The stars overhead tonight are ancient beyond ordinary imagination. Some visible photons began travelling toward Earth before human civilization existed. Others left their stars before mammals evolved at all. The night sky is filled with delayed history, arriving silently across enormous darkness, and yet even this ancient light represents only a fraction of what exists. Beyond the observable horizon, space-time continues expanding into regions forever inaccessible to Earth. Galaxies beyond contact drift through darkness without witness. Entire cosmic histories unfold outside the sphere of human observation. Reality exceeds awareness in every direction. Perhaps it always will. This idea once felt terrifying. Now it begins feeling strangely peaceful. Not because the unknown becomes smaller, because the need to dominate the unknown weakens. Human civilization inherited an instinct to conquer horizons. Oceans were crossed, mountains climbed, diseases studied, matter split apart. The assumption beneath progress was that every boundary could eventually be overcome. Cosmology introduces the first boundary that may remain absolute. Not a technological frontier, a structural one. And perhaps maturity as a civilization involves learning to exist beside mystery rather than imagining mystery must eventually disappear. The observable universe may never fully surrender its architecture to human understanding. There may always remain regions beyond causal contact, laws beyond complete unification, truths beyond observational reach. Yet awareness still matters locally despite this incompleteness. A single conscious life remains capable of wonder, capable of love, capable of grief, capable of looking upward and recognizing the scale surrounding it. The universe does not invalidate these experiences by being large. If anything, the contrast deepens them. A brief moment of awareness occurring inside billions of years of cosmic silence acquires a quiet kind of beauty precisely because it is fragile. And fragility appears everywhere the deeper astronomy looks. Planetary systems form and vanish. Stars ignite and collapse. Galaxies merge slowly across darkness. Black holes evaporate over impossible timescales. Nothing visible escapes transformation. The cosmos itself evolves continuously toward futures no human being will ever witness directly. One day, billions of years from now, the last traces of humanity may vanish completely. Earth will grow uninhabitable. The sun will change. The Milky Way will merge with Andromeda into a new galaxy beneath unfamiliar skies. Eventually, even those stars will die. And beyond all of it, the universe will continue. Expansion will proceed. Darkness will deepen. Entropy will rise. Reality will not pause to remember civilization. Yet for one brief era, amid one temporary arrangement of matter and light, awareness emerged strongly enough to ask what lay beyond the observable universe. That question itself may be one of the rarest events in cosmic history. Not because the answer was found, because the question was asked at all. And perhaps this is enough. Not enough to conquer mortality, not enough to eliminate loneliness, not enough to resolve cosmological uncertainty, but enough to create meaning locally inside an indifferent universe. The observable universe remains mostly silent tonight. Ancient galaxies continue drifting apart faster than light can bridge the distance between them. Invisible dark matter surrounds luminous structures. Dark energy stretches space-time toward increasing isolation. Beyond the horizon, reality extends into permanent invisibility. And beneath all of it, on a small cooling planet orbiting an ordinary star, consciousness continues briefly against the dark, a thin layer of awareness suspended inside enormous silence. Looking outward, still wondering, tonight the observable universe still surrounds Earth in every direction. Ancient light continues arriving silently through darkness older than civilization. Galaxies drift beyond one another across expanding space-time. Invisible matter shapes structures no human eye will ever directly see. Beyond the cosmic horizon, reality extends outward into distances permanently unreachable from here, and most of it will remain unknown. Not temporarily unknown, unknown in principle. There may be stars whose light will never arrive at Earth. Histories forever outside causality. Regions where space-time unfolds without witness. Structures too large for any civilization to fully map. Truths no observer can completely possess from inside the universe itself. Humanity evolved expecting horizons to end. The observable universe reveals a horizon that may not, yet somehow, within this immense and indifferent cosmos, matter briefly learned to ask questions. On one small planet orbiting one ordinary star, biological life became conscious enough to measure ancient radiation from the beginning of cosmic history. conscious enough to detect invisible gravitational structures, conscious enough to realize that the visible universe may represent only a tiny illuminated fragment of something vastly larger, and conscious enough to feel unsettled by it. Perhaps that feeling is unavoidable. The universe was never built to fit comfortably inside the human mind. It is older than intuition, larger than language, stranger than instinct. And still, people continue looking upward, not because the cosmos promises answers, but because awareness reaches naturally toward mystery. The observable universe may be only a temporary window inside an endless reality expanding forever beyond sight. One day, even the galaxies currently visible in Earth's skies will fade beyond observational reach. Future civilizations, if any survive long enough, may inherit a darker and lonelier cosmos stripped of evidence that the larger universe ever existed at all. The night sky itself is temporary. This era of visible galaxies is temporary. Humanity is temporary. And perhaps that is why the universe feels so emotionally heavy once its scale becomes clear. Not because existence lacks beauty, but because the beauty is fragile against deep time, a brief illumination surrounded by enormous darkness. Yet maybe there is something quietly meaningful in the fact that the cosmos became observable at all, that among endless silence and expanding emptiness, reality produced at least one species capable of reflection, capable of awe, capable of understanding, however partially, that it occupies only a tiny region inside a much larger unknown. The observable universe does not offer comfort. It offers perspective. A perspective in which human life becomes small, but no less real, temporary, but no less profound, fragile, but perhaps more precious because of that fragility. And beyond the horizon, the darkness continues, silent, infinite perhaps, still expanding, a reality with no visible edge, only distance beyond distance beyond distance, stretching forever outside the final reach of human observation, while here, beneath a thin atmosphere on the cooling world, consciousness flickers briefly against the cosmic night, looking outward, listening to the silence, and wondering what still waits beyond the light.